The Earth's crust is made up of minerals, and the mineral makeup of our Earth's crust is oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, titanium, and hydrogen. With oxygen, silicon, and aluminum actually being our three top minerals. You can see over in the pie chart that oxygen, silicon, and aluminum are still our three biggest minerals, and then next comes iron. A lot of people think that iron is going to be more than aluminum or silicon because we have an iron core for the Earth. However, it is not that much. Oxygen, silicon, and aluminum being the three biggest ones. Now, where is all of our minerals distributed? We have minerals distributed all over the Earth, obviously, and countries and mineral deposits. We have Canada, Russia, the Congo, South Africa, Brazil, Australia are really rich in mineral deposits. The United States has an abundant energy reserve of coal, natural gas, oil, iron, copper, and tin. Okay? And in the United States and many places, we use aluminum a lot, but actually most of our aluminum, almost all of the aluminum, as well as most of the ores, and remembering that ores means rock that contains the mineral that we want to use, of special metals that are important in making steel like nickel, cobalt, and chromium must be imported from the countries mentioned above. We do have a big steel making facilities here in Wisconsin, and so we have to rely for nickel, cobalt, and chromium to come over from our neighboring countries. How do we get these minerals to be in a usable form for us so that we can make aluminum, tin cans, we can make steel for making buildings, we can have nickel to make some pennies or any other alloyed metal, we can do things with chromium. How do we do this? The best way that we do this is we do one, let's highlight with this. We have, oh, sorry, it's not going to work, is it? We have smelting, and smelting ores to separate impurities from the pure metal, and we will talk about this and we will watch this video. If you wanted to plug that in and watch that on YouTube at home, you're more than welcome to. On smelting, it's a very old-fashioned way of getting our minerals out of an ore. There's also something called leached, which is the use of chemicals or bacteria to minerals from the waste. So we use chemicals or a bacteria to help us to get the minerals from the waste, and we will see a little video on this from Wisconsin in our own backyard of Milwaukee from MMSD. And if you've ever used the product Milorganite on your grass as a fertilizer, that actually is made using chemicals and bacteria called leached. And then we also, the most famous of them all is mining, and that's the extraction of valuable minerals or other geologic minerals from the earth, from an ore body, vein such as coal, steam, or reef, which forms the mineralization horizon and package of economic interest to the miner. So basically, we're going to mine anything out of the earth that we can use to make products for ourselves. And we, in class, are going to demonstrate mining with a very fun lab activity. Who is responsible for looking at what the earth is made of looking at the distribution of minerals, who has what, and how are we going to get them. There are two different types of scientists that we will look at. You definitely have your geochemists, which are geologists who study the distributions and the amount of chemical elements in mineral ores, rocks, soils, and waters, and the atmosphere, and their circulation in nature. So geochemist is going to look at how the chemistry of the geology that they're looking at. What elements are present for that mineral? What other impurities might be there? How is the best way that we're going to separate them? What process are we going to use? Are we going to use smelting, leaching, mining them out? And how does it circulate in nature? We also have a geophysicist. And a geophysicist is a geologist who studies the physical properties of the earth or applies physical measurements to geologic problems. So they're helping us solve the problems that we're having with all of the natural resources that the United States has. For example, where are we going to get our oil? And that is a big problem in the United States that we hear quite a bit about. And drilling for oil, where are we going to drill for oil? And these geophysicists and these geochemists work together to solve these problems for us.